Okay, so in our Pythagorean theorem unit, we've got to identify a couple things within right triangles. So remember that in a right triangle, you've got things called the legs and a hypotenuse. So A and B are called the legs, and C is the hypotenuse. Remember the Pythagorean theorem we learned as a squared plus b squared equals c squared. So we just came off of our isosceles triangle week, and if we have an isosceles triangle, remember that these two sides are equal. If I make two right triangles within an isosceles triangle, what this does to the base, it divides it in two equal parts. So say if this whole base was 8, each piece would now be 4. Okay, and we formed two right triangles. Here's one, and then here's the other one. And those triangles would be exactly congruent, but the major thing that we need to remember about this is that the base here gets split into two equal parts. And that's the same with an equilateral triangle. Remember, an equilateral triangle has all three sides that are equal. So if I make two right triangles within an isosceles triangle, that's still going to cut the base in two. So if all the sides were, say, 10, this would be 10 and then 5 and 5, and we could use the Pythagorean theorem to find the height of this triangle. And you use that in level 3s more to figure out the area of a triangle. And we'll cover that when we get there. Now, we can also use a Pythagorean theorem to figure out if a triangle is right, obtuse, or acute. So if a triangle is right, it will satisfy the Pythagorean theorem. So it will be a squared plus b squared equals c squared. So say if I have a triangle with the side length of 3, 4, and 5. Whoops, 3, 4, and 5. So if this is a right triangle, it would satisfy the Pythagorean theorem. So I know the longest side is going to be the c, so that would be 5 squared. And the two legs, it doesn't matter what you use for a or b. So now I've got 9 plus 16 equals 25. And that is in fact true. So I know that the side, if I've got a triangle with the side lengths of 3, 4, and 5, that is going to be a right triangle. Now the question becomes whether it's obtuse or acute, and we use the same kind of idea that we use for the Pythagorean theorem, but instead of equals, it will be an inequality. So if we have a triangle, say the side lengths are 5, 7, and 10. And we're going to try to see if it's right, obtuse, or acute. So what we're going to do is we're going to take the longest side, that's going to be the C. So for us it's going to be 10. And then A and B will be 5 and 7, because those are the two smallest sides. So I'm going to take 5 squared plus 7 squared, and for now I'm just going to put a question mark, and then 10 squared. So 5 squared is 25, 7 squared is 49, and 10 squared is 100. So now if I add 25 plus 49, that's going to be 74, and I still have 100. So right now I've got 74 and 100. Well, 74 is less than 100. So this tells me since I added up a squared and b squared and it came out to be less than c squared, I know that this is going to be obtuse. Okay. Now, so that's for obtuse. A squared plus b squared is less than c squared. That will be obtuse. Now what happens if it's greater than c squared? That's going to be acute. Now what if we have a triangle with side lengths of 7, 6, and 8? Let's see if we can figure out if it's right, obtuse, or acute. So we're going to take our two smallest sides and square them, so 6 squared plus 7 squared, and we're going to determine if it's not equal to, but we'll just put a little question mark there for now. 8 squared. So we've got 6 squared is 36 plus 49, and then at 64. So if I add 36 plus 49, that's going to be 85, and 85 is greater than 64. So this is going to be an acute triangle. So what we have here are 3 different rules. I'm going to go ahead and erase what we wrote here for the examples, but you can always go back and re-watch it. So we have what we've got. We got our right triangle where it's a squared plus b squared equals c squared. We will also have our acute triangles and obtuse triangles. So if we have a squared plus b squared is greater than c squared, this is going to be an acute triangle. And if we have a squared plus b squared is less than c squared, this is going to be obtuse. So a couple different things that come off the Pythagorean theorem, but it's not just always used to find out if it's a right triangle. We can use it to find out if it's obtuse or acute based on how big or how small the hypotenuse is. Let's go ahead and look at the Pythagorean triples now. So we know how to use the Pythagorean theorem. We can always find a missing side to a triangle, but these things called the Pythagorean triples are really nice to kind of memorize and get the hang of because they'll just make problems a lot easier. Pythagorean triples are a set of numbers, a set of whole numbers, integers, that satisfy the Pythagorean theorem. So like 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared will equal 5 squared. Same thing with 5, 12, 13, and the rest of this list. And there's a ton more Pythagorean triples that exist out there, and there are definitely multiples of them too. So if you have 3, 4, 5, you might also start to recognize the more we do these that there's a Pythagorean triple that if I multiply each side of the first one by 2, a 6, 8, 10 is also known as Pythagorean triple, but it's a multiple of the 3, 4, 5 one. You can multiply it by 3 as well. Okay, it could be 9, 12, 15. So it's just a good idea. You'll start recognizing and picking up these patterns, but it's just a good idea to maybe memorize a couple of these. They just make the Pythagorean theorem a lot easier, a lot quicker if you do recognize. They'd say like, hey, I've got a triangle that's got a 5 for a leg and a 13 for hypotenuse. Oh, I don't even need to do that third side to find out what that is. I know it's 12 because I know the triples. So those are just good things to remember, good things to know. You can always use a Pythagorean theorem to go back and figure it out, but it is a good idea and really helpful to start learning those. For number 4, just a quick review. I just want to go through with you how to find and how to use a Pythagorean theorem in terms of squaring, square roots, and numbers. So find the length of hypotenuse, so that is c. So I know a and b. Just remember that when you do a squared, you always put it in parentheses because you do want to just make sure that you're squaring each number. So remember, if I square this, it's going to be 2 root 3 times 2 root 3. I'm just going to write everything out. Plus root 15 times root 15, which will equal c squared. So now I'm going to multiply number times number and root times root. And then same thing with root 15. Now you don't have to show all these steps, but I like to just to make sure that we're all on the same page here. So 4 times root 9, well root 9 is just 3, so 4 times 3 is 12. The square root of 225 is just 15. That's going to equal c squared. So 12 plus 15 is 27. So if I square root both sides, I got the square root of 27, which I'm going to break down off to the left here into 9 and 3, 3 and 3. So a 3 can come out. And that's going to equal c for letter A. If we're looking to find the area of a triangle, remember the area of a triangle is going to be 1/2 the base times the height. And now the base and the height must be perpendicular. Okay, remember perpendicular is that upside down T. It must be where the two sides form the right angle that you're using the base and the height for. So for this problem, we've got the area equals 1/2 2 root 3 times root 15. And I'm going to go ahead and multiply these. Right away I noticed the 1/2 and the 2. 1/2 times 2 is just 1. So I'm just going to multiply 3 by 15. So I'm going to get the square root of 45, which can be broken down into 9 and 5. And the square root of 9 is 3. So a 3 can come out. And we're just left with 3 root 5 for our area. So now we're going to find our perimeter of our triangle, adding up all three sides. So we've got 2 root 3 plus root 15, and then what we found for C, which was 3 root 3. Root 15 can be broken down to except for 3 and 5, and there's no pair, so that's as simplified as it can get. And you can add 2 root 3 plus 3 root 3 because they have the same roots. So 2 root 3 plus 3 root 3 is 5 root 3. Remember, you don't change the radical when you're adding, and then you just tack on the square root 15 on the end. So 5 root 3 plus root 15 will be your perimeter. Now I just want to throw in a couple tangent questions just to keep us fresh on these, because we will use these later. But the tangent of angle A, remember, tangent we find as opposite over adjacent. So from angle A, let's put angle A right here. So from angle A, the side that's opposite is going to be the 2/3, and the side that's adjacent to it is going to be the root 15. So 2 root 3 over root 15. And now I'm going to simplify. So root 3 and root 15 I can simplify into 1 and then root 5. So I got 2 over root 5, and now I'm just going to rationalize. I'm going to multiply top and bottom by root 5. So am I finding that to be 2 root 5 over 5. Now the measure of angle A, this is where you use the inverse tangent. So you say tangent inverse of that same ratio, 2 root 3 over root 15, or you could use the 2 root 5 over 5, and you'd use your calculator to find that answer. So in your calculator, just hit second tangent and then put in that ratio, and you'll come out with a measurement in there. So that's basically level 2s for our Pythagorean theorem. Just wanted a quick highlight, squaring square roots in terms of just using the Pythagorean theorem, introducing you to Pythagorean triples, and then using the Pythagorean theorem in order to determine whether something's acute or obtuse in addition to a right triangle. And then a couple things in number 1, where you have an isosceles triangle and you draw in the height, what happens to the base. So just a couple things to remember as you're looking through your practice 2 questions tomorrow.